So I will be using the Microsoft CNTK library, the cognitive toolkit, to train and run a deep neural network in C#. So there are many kinds of neural networks that I can build with the CNTK library. So here's an overview. This overview is not even complete. So you can see I can build a feed-forward neural network that's at the top, in the middle of the top row. But in this application, I will be building a deep convolutional network, a deep convolutional network, and you can see it's listed in the bottom left of this diagram. So a deep convolutional network has a very specific architecture, and it uses very specific layers. If you look at the network, you can see there are purple layers. They're called convolutional layers, and we have green layers, and we call those dense layers. And by combining those two, we create a deep convolutional neural network. So here's another view of the neural network that I will be building in code. So you can see the network has 4 convolutional layers. Every convolutional layer is followed by a pooling layer. At the end, we have one dropout layer, the red layer that you can see right there. And then we have 2 dense layers at the end. So this is a very specific neural network architecture that works really well for identifying objects in images. So if we want to identify something in an image, this specific setup of neural network works really well. And we discovered this architecture by looking at the human eye. By looking at the human eye and the retina and the optic nerve behind the retina, and really taking that apart and looking at the neurons in the optic nerve and how they're wired together, scientists discovered that the human eye uses a certain process called convolution to recognize objects, to be able to recognize objects. So here we're just simulating that same process in a computer. So those green layers are convolution layers. So this is a simulation of how the human eye basically works, how the human retina detects objects. So this setup will detect objects in images. Now, to be able to work with a neural network, we need to load data in memory. Then we need to train the neural network on the data. So basically, we show images to the neural network over and over and over again. And we allow the neural network to make predictions. So we show a dog, and the neural network says, I think that's a giraffe. And then we correct the output. We say, no, 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 it's a dog. And then the neural network will recalibrate itself and try to match these correct predictions. So it starts out with a giraffe prediction, which is completely wrong. And then it will try to converge towards dog, to get that right. And then I can show a cat. And then the neural network will say, well, that looks like a mouse. Nope, it's a cat. And then we do the whole process again. So for thousands and thousands of images, we show the image to the neural network, and we allow the neural network to reconfigure itself to generate the correct predictions. And this is the training process of a neural network. Once this process is done, the neural network is completed, it's fully trained, and then we can just run it. We can show it images, and the neural network will say, that's a dog, that's a cat, that's a mouse, that's a snake, etc. And we have built ourselves an animal detector. It's that easy. So there's always this training loop first, where we train a neural network, and then when the network is fully trained, we use it in business applications. So what I'm going to build today, and you're going to love this, I'm going to build the hot dog detector from the Silicon Valley TV show. If you've never seen this particular clip, I invite you to Google it right now. Look it up on Google, look it up on YouTube. It's a hilarious application that uses a mobile phone to analyze food, and the only thing it can do is identify hot dogs. So if you point your camera at a hot dog, it will say, yes, that's a hot dog. And if you point the camera at anything else, it will say, that's not a hot dog. So this is a hilarious application from the Silicon Valley TV show, and I'm going to build it. So let me show you what that looks like. So here's the code. I'm very quickly going to walk through this code because I want to keep this video short. So look, this is C# code, right? There's no Python, it's all C#. And it's here I'm constructing my neural network. So the neural network architecture that you saw a few minutes ago is right here. Look, convolution layer, pooling layer, convolution layer, pooling layer, convolution pooling. Here's the dropout layer, the red one in the architecture, and then the 2 dense layers, the blue layers at the end, and that's the whole neural network. So this is how you build a convolutional neural network in C#. And then, I scroll down, I have to train it. So here's a training loop. So this bit of code trains the neural network on images. And then here's a second loop, and this loop checks the trained neural network. So I always train the neural network, and then I show it a couple of test images, and we do a quick test to see how good it's doing. So by testing continuously, I am able to measure the quality of the predictions during training. So during training, I can see how the network gets better and better and better at identifying hot dogs. So to show you the data, here's my data set. So I've got a data set of hot dogs. And well, you can see most of them sort of look like a hot dog. So here's obviously a hot dog. Well, it looks like a hot dog. But look at this one. It's like someone's eating a hot dog with a slice of watermelon on the bread as well. So that one's difficult to recognize. Now look at this one. Believe it or not, this is the hot dog. So the neural network has a challenge here. It's actually not easy to identify these hot dogs. So I'm going to train the neural network on this list of images and tell it these are hot dogs. And I also have the other data sets, it's right here. These are images of everything that's not a hot dog. So you can see we have lots and lots and lots of images of all kinds of fast food, all kinds of terrible fast food dishes that will probably kill you with the cholesterol that they contain. But they are definitely not hot dogs. So I've got 500 images of not hot dogs, and I've got 500 images of hot dogs. I will train my neural network. I will tell it if it's looking at a hot dog or not every time, and the neural network will continuously reconfigure itself and try to get better and better and better at predicting hot dogs. So this is a .NET Core application, .NET Core version 3, which means I can simply run it like this, .NET Run. So this is a C# console application which builds, trains, and runs a neural network. Look at that, it's running. C# code, no Python anywhere. Now the neural network, you can see it has 3.4 million trainable parameters. That means every time when I show one image to the neural network, it needs to reconfigure almost 3.5 million parameters to optimize its predictions. 3.5 million parameters. And I have 1,000 images. So 1,000 times it's reconfiguring 3.5 million parameters. And that is for every single loop epoch that you see here. So it's done that 9 times already. So training a neural network is a massive computational exercise. It takes massive computational resources. It's reasonably fast on this computer because I have an NVIDIA GeForce 1060 GPU in this laptop, which makes training neural networks quite fast, quite speedy. So that's pretty cool. So this will take 100 iterations. It takes a bit too long, so I'm going to abort it here, but I'll show you the finished graph. So this is what the final graph looks like. So you're looking at the accuracy, that is how accurate the hot dog predictions are. Maximum accuracy is 1, which means that every prediction is correct. The worst accuracy is 0, which means every prediction is incorrect. Neural networks always start at a random chance, which is at 0.5. So you can see I am starting at 0.5, and then the predictions slowly get better and better as I train longer and longer. And eventually, after 100 training epochs, you can see that my neural network has a 96% accuracy on the training data. So it is 96% accurate at identifying hot dogs in the training set. And the test set, the test images that I show to test the neural network, it scores a 66% accuracy. So 66 out of 100 times, it is able to correctly identify a hot dog, which I think is pretty cool. The big difference between those two numbers, that is a complicated story. I'll tell you all about that in the course, in the machine learning course. So let's get back to that. Let's get back to the machine learning course. So I have created a set of 4 courses that will teach you how to become AI and machine learning experts using C#. I've got a course on data science. It will walk you through all the data science algorithms that are important in the field of machine learning. I've got a course on C# and CNTK, and it will teach you how to build and train neural networks in C# on your own computer and use them for all kinds of cool stuff. So this specific code example, the hot dog, not hot dog detector, is in the course. I just showed you code that is actually in the course. So you will be building your own hot dog detector and attempting to get it as accurate as possible. You're going to try and get that accuracy as high as possible, close as possible to 1.